Great. Well, thanks so much for having me here, Russ, Zach, and thanks for giving me the opportunity to present about experimentology. CORS is such an important center. It's so important that we champion these key scientific concerns to the broader university community. So I appreciate you being here and engaging. And this is fun for me because I typically present to audiences about my domain research. And here I get to talk a little bit about my teaching. And in particular, talk about my book, Experimentology. This is a textbook that is forthcoming from MIT Press this spring. And I get to say this, you don't buy my book, right? Because it's an OER, it's freely available on the web. If you want it printed out, you can have it, but it lives online. So why did I write a textbook about experimental methods? As somebody working in experimental psychology for the last 15 years, I came of age during what we call the replication crisis. So shortly after I arrived at Stanford, I had the privilege to take part in this first mega study in experimental psychology, where 100 different groups around the world replicated published papers. And 4 of those replication dots on this graph here came from my very first class that I taught in experimental methods, including one by Maya, who's now associate director at CORS. And unfortunately, they were the red dots down there at the bottom, as were the majority of dots. So this suggested that in the hands of naive groups just reading the published report trying to replicate an experiment, problems ensued. We didn't always get the same empirical result with the new sample. Now this was kind of a great study one, as we like to say in psychology, but lots of thought-provoking ideas came about from it, lots of flaws also, but it itself was replicated in a variety of different ways. One was through new data collection, but another that was maybe even more concerning for me was the fact that before you even go and collect new data in a psychology experiment, if you just dig into the numbers from a published paper, you often find that there are puzzling issues. Sometimes when you just look at the statistical reporting, it's literally logically impossible for particular statistics to be truly reported. And so this really radicalized me as I was starting my career. I started to think, how do we need to change our practices as folks working in this field? And it became clear to me that one key way forward was the open science movement as a key driver of change, and that transparency itself could be a protection against some of the really negative scientific outcomes that I was worrying about. For example, the idea is that people sharing their code, sharing their data, and releasing their statistical analyses would lead to greater reproducibility of the numerical results in their papers, and their release of all of their materials and data and so forth might lead to greater replicability of their findings in new samples. But as I started to embrace this broader worldview, which is a constellation rather than a single North Star, as Angela so nicely said, I realized that people need support in this transition to open science. It's not enough to just say, be open, okay, just put it on the web. People have all kinds of concerns, there are all kinds of technical barriers and obstacles, and so I really started to weave that into my teaching. So for the last 15 years, I've been teaching experimental methods, which is a class that's required for graduate students in psychology as they start their program. It's been taught every year except for this year where I'm on sabbatical for the first time. But it'll be back in next fall. And I love teaching this course because it sparks so many interesting discussions with graduate students who are really thinking, how do I contribute to this field? How do I engage with the practices that I'm learning as a kind of new craftsperson in psychology? And so a couple of years ago, my collaborators, co-authors, co-TAs, and I decided to write up some of those ideas into a more of a consistent guide to these folks who are taking the class as a textbook. And so my co-authors here are a wide variety of folks who TA'd for the class or came through my lab over the years, including Maya, who never TA'd for the class but took the class as an undergraduate, as a star student, and now is back as the author of the statistical material here as the expert statistician in our midst. And I also want to give a lot of credit here to Amika Brzezinski in particular, my longtime co-author who really did all of the technical work underlying this book. So we decided early on that it was critical for this book to be as open as the practices that we were trying to teach. And in fact, that there would be some kind of recursivity there because we would show people how to share things online through a book that itself was shared online. So we built in a whole variety of features. My favorite is the cute little line drawings, all made with the finger in PowerPoint and probably look that way too. But also, we have Mika to thank for web native content, so features that try to make the instructional experience a little bit customizable, meaning folding up boxes, kind of finding places to go into depth or link to other content. The consistent integration of code, so the ability for students to dig deep into a particular concept by then linking this to specific executable code that's linked in an ARC package, and a set of interactive online tutorials that they can work through to get some of the technical prerequisites. Because even though this isn't a technical book per se, in order to appreciate some of the things that we're trying to do around code sharing, around data sharing and reproducibility, there is a minimum technical barrier that folks need to hit. So as I mentioned, Experimentology is all up on GitHub, just like Matthew was talking about. This means that we're a project that can be forked, that can be contributed to. People can post issues, make pull requests when they find errors. And indeed, we have found folks really coming in and helping us with this. We posted on social media that we were in review, that we really would value people's feedback, and to our surprise, people did show up and show us the typos and the problems or our issues in connecting to Zenodo because our DOI wasn't right. That's Zach in there in the mentions. But Russ pointing out some questionable statistics that we were recommending and so forth. All my fault, not Maya's. And so this has been a really fun exercise in this community sourcing of feedback. And I think the great thing about this is that even though we are technically going to press, in fact, as we teach from this book, we are really going to be continuing to update, continuing to build things out. And indeed, when I got the jacket blurb from a longtime kind of mentor and friend, I wrote, "Thank you for this nice jacket copy," and he wrote, "You know what? What you really need is an extra chapter on this other topic." And I didn't say it in the jacket copy, but I'm saying it to you now. You're missing this chapter. And I thought, well, okay, here's our opportunity. And of course, the really wonderful thing is that this kind of work can enable other work. And so one of the most flattering things that I've seen from Experimentology is that there's some other online open books that are popping up around Stanford that look suspiciously similar. So this is my collaborator and friend, Jason Yateman, who works on this amazing rapid online assessment of reading product. And he just, he reached out to us and said, "Hey, I don't want to come up with my own formatting. I want to come up with my own content. Can I use your formatting?" And you may hear soon about Machine Learning from Human Preferences, another amazing textbook with a suspiciously similar formatting. So I think this is fabulous. It's really fun to see ideas have a life outside of the single vessel that you put them into. Okay, so I just want to end by mentioning that we're trying to move onward. I'm incredibly inspired by all of the work on open educational resources and would like to contribute to that, not just in my own teaching, but also in my broader disciplinary context. So with really generous support from MIT Press, I've been co-editing a new resource called the Open Encyclopedia of Cognitive Science. So the idea here is that we've got field-leading scholars writing introductory articles on cognitive science. The amazing thing about cognitive science is there's no single intro to cognitive science course that's the same as any other cognitive science course. Everybody's got their own take on it. And so our vision here is that instructors can look at the network of different concepts that are out there, browse this, remix them, put them together, and create their own vision of what cognitive science is. So the idea here is really to leverage social communities that already exist and creating a field-specific OER that enables scholarship and instruction in cognitive science. And so that's what we're at work on now. Happy to talk more to anybody who's interested in this, and thank you very much.
Sort of a mechanical detail, but as you're talking about the authoring systems for working together on the book and GitHub and how much the world and environment of writing have changed, how are you finding or finding practical works in your co-authors on using AI to help co-write and keep things up to date or to refer to data sets and kind of groom and keep text going? Or is there any particular differences between kind of the usual ways that we might use AI to help in our writing that are different in this collaborative, more wiki-like form?
Oh, that's a wonderful question, and it's one that we didn't have to grapple with because it was like 50 AI years ago when we finished Experimentology, meaning it was like the end of 2003, right? So what I think I'm really struggling with and thinking through is what is the value proposition behind Open Encyclopedia of Cognitive Science in the age of AI when you can just ask a question. and get some summary on many, not all, but many of the topics that we were talking about. And so a lot of what we do is we look at our articles and then we look at the article that would have been generated with our template by a bunch of these systems. And what I think we can offer is the coherence of scholarly perspective, right? The trust and the perspective taking that we offer really helps people navigate complex, controversial, and challenging topics. So you can get an AI-generated article on the relationship between language and thought. This is like a kind of a classic cognitive science debate topic, and you would desperately not want to assign this article in your intro class because it takes a completely, all of these articles that are generated, they're incoherent and confusing in different ways. Not that they're wrong, but the perspective of a scholar is kind of missing from them in really important ways. And so what I think we do is we try to create those islands of real coherence and perspective in this instructional landscape. And then, I think it's quite possible that we could use AI tools to connect those islands in really interesting ways, to introduce them, to transition them, certainly to translate them. We're already working on that. But we have these unique expert perspectives that anchor the resource. And so that's the way I'm thinking about it, but I'm also really open and eager to learn how best to leverage these tools, which we already use in research in our material construction.
I love that benchmarking, the idea of subtracting the online encyclopedia entry from what the AI would have generated to calculate the value above replacement for the scholar.
It's still positive, I'm happy to say.
Yeah, hi. I'm into CS, computer science, the other CS. So coming to cognitive science, where I have not dabbled much, you made the comment that there are a lot of ways to interpret cognitive science. Different people have different take. So isn't there a formalism of what cognitive science is if I went to 10 people who were experts in cognitive science?
I think this is one of the wonderful things about the project of cognitive science. So you'll see cognitive science, intro to cognitive science classes living kind of in a disciplinary way in a university in their own program or in their own disciplinary home. You'll see them in a psychology department, in a neuroscience department, in a computer science department. And so I think, the founding of the Cognitive Science Society in the late 70s, there's this, they call it the hexagon, right? It's psychology and linguistics, computer science, philosophy, education, anthropology. It's like the vision, interdisciplinary vision of what cognitive science is. And so a lot of what we do when we teach this topic is choose a perspective. Are you taking a human-computer interaction take on cognitive science, or more of like a psychology and kind of computational mechanism take, or maybe a perception science take, right? There's all these different ways to present cognitive science. And in some ways, that's it makes it more complicated to say that there's just one disciplinary canon, but also more exciting because it connects to so many of the most core questions that we're asking about today, from the role of LLMs to the relationship between language and thought to political polarization, right? Those are all topics we have articles on in OX. There may be not just one course in the university, but they're core.
Thank you.
Awesome. Thanks again.
Thank you.